Okay, so we're going to solve, okay, water plane of a ship. So what is water plane area of a ship and why are we concerned about this? So water plane or WP area of a ship is the area of the hull at which the vessel is afloat. For a box ship vessel, it would simply be the length times breadth. Okay, so as it is not symmetrical for a ship, it is calculated by a formula known as the Simpson's rule, which provides the area of four ships shape. Okay, the water plane area is used to calculate the displacement of the vessel for different draft and also to determine the longitudinal center of flotation, or the TPC, tons per centimeter for immersion. The formula for which is density times area divided by 100, where D is density of the water in which the vessel is afloat and E is the water plane area at the draft. Okay, so okay, just a moment, huh? Okay, so okay, so I will show you here an example for the computation of Simpson's rule. So here, so in normal rectangular shape, a box shaped vessel with a length of 96 meter and a breadth of 20 meters. So the formula is water plane area equals length times width. So it is very simple. The answer is 1920 cubic meter. So but for the shape, so let's say for example here is the perfect rectangular area or box. So what about the curve in the forward part? So we are going to solve Simpson's rule number 1. The formula here is area equals 1/3 times h. What is h? So this one, the distance of each ordinates, 5, 5, 5, 5. So we said that this is 20 meters in breadth. So we will divide this into 4. Therefore, each distance per ordinates is 5, 5, 5, 5. So this is h. Okay, so the formula again, 1/3 times h times 1a plus 4b plus 1c, etc. Okay, so now we will draw this one, the curve. Okay, curve from here. So we will put an ordinates 1, 2, 3, 4, 5, 5 ordinates. We will mark it as A, B, C, D, and E. So each distance here from A to B is 5, from B to C is 5, C to D is 5, D to E is 5. Okay, so the distance from here to here is 5. So E is obviously 0. So distance here is 5, and then C is 6, and then D is 5 meters. Okay, so we will now draw a table. Okay, table. Okay, okay, so this is E, the ordinates, right? And the distance of each ordinates. So A, the distance is 0, obviously 0, and the B is 5, C is 6, and D is 5, and E is 0. So we will now go into the multipliers. So as per Simpson's rule. So anyway, in your quiz, this is no? This will be given. I will put this in, include this in the questions. Okay. So in the Simpson's rule 1, if 5 ordinates, therefore the multipliers are 1, 4, 2, 4, 1. Okay. Okay, so that's the rule 1 of Simpson's rule 1. So we will going to multiply this one. 0 times 1 equals 0, 5 times 4, 20, and so on, 12, 20, 0. The total, we will going to add this one. The total is 52. Okay, so we will apply the formula. So formula is 1/3 times 5. Again, this is h, this is 5, the distance of each ordinates. So times, okay, 1 times 0, this one, a, see, and 4 times 5, and 6, okay, 2 times 6, sorry, and then 5 times 4, and then 1 times 0. Okay, so the total is 52. So, okay, now let's go to this part. So, how are you going to convert this into whole number? So, just simply 1 divided by 3 equals 0.33333. So, times 5 equals 1.67. Times 52, the area is 86.84 cubic meter. So, the area in this place. Okay? Since we already know the area of this perfect rectangle, we will going to add so that we can determine the whole water plane area of the vessel. So, water plane area here, as you can see here on the perfect rectangle is 1920 cubic meter. So we will add this one, 86.84 cubic meter. So the total is 1886.84 cubic meter. So that is for rule 1 of Simpson's rule in finding water plane area. Okay, so now let's go to example number 2. Now we are going to use the Simpson's rule number 2. So what is the area of water plane using Simpson's rule number 2? The common interval is 15 feet and the ordinates are 0, 9, 13.3, 14.7, 12.8, 7.5, and 0.6 feet. So solution. So first we will make a table, a column, and then we will put A, since this is 1, 2, 3, 4, 5, 6, 7. So this is 7 ordinates. So A, B, C, D, E, F, G. So each ordinates has an equivalent of 0, 9, 13.3, and so on. So we will going to multiply here as per Simpson's rule. If 7 ordinates, so this is the multipliers. Okay, 1, 3, 3, 2, 3, 3, 1. Okay, so again, okay, again, 0 times 1 equals 0, 9 times 3 equals 27, and so on. And then put the total, 157.6. Okay, so let's go to the drawing. Okay, but in this case, this area is on the half side of the vessel. So this is the forward and the aft. So we will now draw the ordinates A, B, C, D, E, F, G. So each has a distance of 15 feet, 15 feet, 15 feet. So this is H. Okay. Okay. So the distance here is 9 feet, 13.3 feet, 14.7, 12.8, 7.5. Okay. So we will now use the formula of Simpson's rule number 2. So what are the formula of Simpson's rule number 2? 3/8 times each, okay? Then times A plus 3B plus 3C plus 2D, 3A, 3F, and G. Okay, so 3/8, how are you going to convert this one into whole number? 3 divided by 8. So 3 divided by 8 equals 0.375 times 15 equals 5.625. Okay, times 157.6 equals 886. Moment. 3 divided by 8 equals times 15 equals times 157.8 equals 887.6 square feet. Okay, so this one is from here also, no? Okay, so the water plane area is 887.6 square feet. Okay, 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 okay. So I am now going to discuss the Bloch coefficient. So Bloch coefficient is the ratio of the underwater volume of the ship to the volume of the circumscribing block. So this is the circumscribing block. Okay, so the formula is Bloch coefficient, ship displacement in cubic meter divided by length times breadth times drop. Okay, so let's have an example. If the ship displacement is 17,500 cubic meter, her length is 100 meter, breadth is 20 meter, drop is 10 meters. So calculate the Bloch coefficient or CB. So solution, Bloch coefficient is 17,000 equals 17,500. This is the displacement divided by length times breadth times drop. So this is 20,000. So 17,000 divided by 20,000 is equals 0.85. That is your Bloch coefficient. So as you remember, the formula in getting displacement is like this. Okay, length times breadth times drop times Bloch coefficient times density of water. So you can find this in the hydrostatic table. So this is very easy and simple. Okay. 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 So now let's go to the calculating of TPC or tons per centimeter immersion. Okay. So example is a ship of 150 meters in length, 20 meters in breadth, and has a coefficient of 0.83. Solved for TPC. She is floating in salt water with a density of 1.025 tons per cubic meter. So solution. So the formula is TPC, length times breadth times the Bloch coefficient times seawater density divided by 100. So TPC is equals 140 meters times 20 meters times 0.83 times 1.025 tons per cubic meter divided by 100 is the answer is 23.82 tons. So this is uh, calculating on how to calculate the TPC, okay, of your diesel. So anyway, this you can find this in your stability booklet on board the ship. Okay, so how about if the given is the area of water plane? So there is also a formula for that in finding TPC. So TPC equals area of water plane times 1.025 divided by 100. So let's say, for example, your area of water plane is 978.3 cubic meter times 1.025 tons per cubic meter divided by 100. So you will cancel this cubic meter and the remaining is tons. Okay, tons. Okay, so the answer is 10.02 tons per centimeter because you are using TPC, tons per centimeter. Okay, okay, so